And here are solutions for quiz 2 for Math 111. Simplify each of the following expressions by writing it without any radicals or exponents. What I'm saying is, I don't know, simplify this guy. So a few ways you can do probably all of these problems. But this first problem, what comes to mind for me is what we refer to as Rule 3. Maybe I'll write these up here for your reference. Rule 1 tells you that when you're multiplying together these two exponents and you have the same base, all you got to do is add the exponents. Rule 2 tells you that when you have an exponent raised up to another exponent, and you can just think about that as your new exponent is a product of those two. And Rule 3 tells you that, let's see, what do we make Rule 3 in this class? Oh, right, when you don't have the same, if you don't have the same base, what can you do? Well, just so it turns out that if you have the same exponent, then there is something you can do. You can multiply those two bases and raise that up to the exponent. And then there are consequences of these rules that we wrote down in class, but I think I'm going to leave it with just these up here to reference and go through and talk about these. So this one is really a special case, or not even a special case, a straightforward application of Rule 3. Playing the role of x is 2, playing the role of y is 8, and I have the same exponent. So that tells me that I can rewrite this as 16 to the 1/2 power. But raising something to the 1/2 power, this is one of our consequences, is the same as just taking the square root of that thing, and the square root of 16 is the number 4. So this answer would just be 4. This problem here, lots of different ways that you could do it. I don't know, maybe I'll even write a couple down. Option 1 is you could, I'm going to first get these out of radical notation and write them all in exponent notation. So I got 3 to the 1/3 over 3 to the 1/2, and I'm raising that up to the 6th power. And so option 1, I could subtract these two exponents, and that is a consequence of Rule 1 that tells you when you have the same base, instead of adding these exponents, if you're dividing them, you can subtract. So 1/3 minus 1/2 would give me 3 to the, let's see, 1/3 is the same as 2/6, and 1/2 is the same as 3/6. And if you do 2/6 minus 3/6, you'll be left with negative 1/6. And then remember that that entire thing is raised up to the 6th power. So 3 to the negative 1/6 to the 6th power, well, now it looks like I could apply Rule 2 here. I could rewrite this as 3 to the negative 1 power. And then one of our consequences says that if you raise something to a negative exponent, that's just the reciprocal of raising it to the positive exponent. In other words, this is 1 over 3 to the 1st power, aka 1/3. And one more way, just because I think there's lots of other ways you could do this, but I suspect that the two ways that people will do most commonly will be to do something like this, or to take this 6 and kind of distribute it in the numerator and the denominator. So to rewrite this as 3, let's just make it 3 squared divided by 3 cubed. Where's that square come from? Maybe I'll do that in the next step. No, I think you can follow this. I'm taking the 1/3 times the 6, and 6/3 is the same as 2. And then I'm taking the 1/2 times the 6, and 6/2 is the same as 3. So I get 3 squared over 3 cubed. And now I can subtract those two exponents and call that 3 to the negative 1 power, aka 1/3. And lots of other ways. I'm sure there's an option 3. Maybe I'll even write or ... Lots of different ways you can do these, but your answer should always be 1/3. Just like your answer up here should always be 4. Number 3, the 40th root of 5 to the 10th power. Wow, okay. Divided by the square root of 5 raised up to the 9/2 power. You can see that these are getting a little bit nastier. I guess you could figure out what 5 to the 10th power is, but it's a number so large that you'd spend all day calculating it, and then try to figure out what the 40th root of that is. I don't know how you do that. I mean, you try with the calculator, but you get some decimal. Instead, what you want to do is apply one of our consequences that says that when you have fractional exponents, the numerator kind of goes here and the denominator goes here. What I'm trying to say is this is just 5 raised up to the 10/40th power, just like this is 5 raised up to the 9/2 power raised up to the 1/2 power. So 5 to the 10/40th, well, 10/40th is the same as a quarter. And 9/2 raised up to the 1/2 power, I guess I could use this second rule to multiply the two of those together. 9/2 times 1/2 is 9/4. So now I'm in a circumstance where I could subtract these exponents. I could take 1/4 and subtract 9/4. and that would leave me with negative 8/4, aka negative 2, which is the same as 1 over 5 squared, or 1/25. Probably could cut out a couple of these steps in there. Maybe you could go straight from here down to here or something. I don't know. But I'll show a couple of extra steps just because maybe that'll help people follow. Yeah, probably other ways you could do this too. I don't know. Nothing comes to mind immediately for me, but I'm sure there's other ways you could do it. Always are with exponents, but this is the answer I'm looking for. Last one here. Really, I put this one on here as what not to do. Because I think what a lot of people are tempted to do is, I don't know, either try to add these numbers up, call it the square root of 10 or something, and then square that thing and call your answer 10. Wrong. Or take this square right here and kind of distribute it down to each of these and call it 2 plus 8 and 10. Again, not correct. Sounds nicer than wrong. What you want to do in this case is recognize that we don't have a rule that deals with a sum of things raised up to an exponent. In other words, you're forced to kind of FOIL this thing out. So what you have to do is think about this as the square root of 2, or 2 to the 1/2 power, whatever you're more comfortable with, plus the square root of 8 times the square root of 2 plus the square root of 8. And so when you FOIL, you take the square root of 2 times the square root of 2, and either you just recognize that that's 2, or you say, wait, multiplying it by itself, that's squaring. So root 2 squared would be 2. Or you could say I have the square root of 2 times the square root of 2. Well, I have two exponents with the same base, 2. They're each to the 1/2 power. So I'll add up those 1/2s and get 2 to the 1 power, 2. Or you could apply this rule here. Okay, I'm beating this thing to death. Lots of different ways you could get to this times this is 2. The O in FOIL would have you multiply this root 2 times this root 8. And so now I have different bases but the same exponent. So maybe I apply rule 3 here and recognize that 2 to the 1/2 times 8 to the 1/2 is 2 times 8 to the 1/2. 2 times 8 is 16. So I get 16 to the 1/2. I'll write that. The square root of 16. And then same thing with the I in FOIL. Root 8 times root 2 would give me root 16. And the square root of 8 times the square root of 8, maybe that gives me an 8, or the square root of 64, which is equal to 8. And then finally, I'll take 2 plus 4 plus 4 plus 8. There's 10, there's 8 more. It looks like I get 18 for my answer. Note that that's not 10. Like I said, you can't just distribute that exponent in there. I guess that ends the quiz. That's the last of the 4 problems, so I'll stop this video here.